So this is a SIA 81 May 2010 question on thermal physics. So a lot of the time they might give you a graph and they might ask you to find the gradient from the graph or link the graph to a thermal equation, and this is what it is in this case. So here we have a graph of pressure against 1 over volume, because we know that pressure is inversely proportional to volume. So we know already we have pressure, we have 1 over volume, and it says for a set of results it gives us the gradient. Okay, so the gradient gives us, show that the temperature, so we're wanting to find what we have, T, and contains this number of moles. So when I look at all of these 4 things, what we want to find or prove, and the other things we've been given, you have to think of an equation that involves all 4 of these, sorry. So we have PV is equal to nRT. Okay, so that is our equation. This here is a constant, so that's why I can include it, because it obviously does not change. Now we have to, in order to show the gradient is equal to this value, and show what the temperature is, we have to link this equation here to the equation y is equal to mx, the equation for a straight line. So what we have to do first, we look at what's on the y-axis, and the y-axis is pressure and only pressure. So I'm going to have to get rid of this volume. So I'm going to divide both sides by the volume. So I'm going to get P is equal to nRT divided by V. Okay, so there's my y. Now what's on the x-axis, we said 1 over volume, which is what we now have. So this here is my x. So that means that my gradient has to be equal to nRT. Okay, so if we're proving the temperature, we're going to have to rearrange that equation for temperature. So it's going to be the gradient value divided by n times r. So the gradient value gives us 12,200 divided by the number of moles, 5.3, multiplied by 8.31, which is the constant value for R. And when we do that, we're going to get a value for T, and it's going to be 277 Kelvin. But the answer they don't want is in Kelvin, it is in degrees Celsius. So in order to change from Kelvin into degrees, you have to take away 273, okay, and that's going to give us 4 degrees, which is what they want us to show, so it's simple enough. Okay, this next one here is saying on the axis of the graph above, draw a line to indicate the results of a similar experiment, except the gas is of a higher temperature. Now, because looking at this, it is again a y equals mx equation. P is proportional to T. For a higher temperature, it's just going to be a steeper line. So if I had a ruler, I'd be drawing that straight like that. Okay, so any line that starts from 0, 0 and goes above, will give a steeper gradient than the current line we have, is the correct answer.